First and foremost, introduction to mathematics. In UTME, we have 50 questions to be answered in less than 60 minutes. It means that we have less than 1 minute to answer a question. The general objectives is the aim of the Unified Tertiary Matriculation Examination, UTME, syllabus in mathematics is to prepare the candidates to the board's examination. It is designed to test the achievements of the course objectives, which are to acquire computational and manipulative skills, develop precise, logical, and formal reasoning skills, apply mathematical concepts to resolve issues in daily living. The syllabus is divided into 5 sections. The first section is number and numeration. The second section, algebra. The third section is geometry and trigonometry. The fourth section is calculus. The fifth section is statistics. The way I will go about all these sections is to pick the section one by one and discuss the subtopics under each section. The first section, we talk about numeration and number. Under that, we have number bases, fractions, decimals, approximation, percentages, indices, logarithm, sorts, and sets. The objective: candidates should be able to perform 4 basic operations plus multiplication, division, and subtraction. Secondly, convert one base to another. Let's look at most commonly tested UTME questions on the topic under discussion. Example: if x base 10 is equal to 23, find x. In this situation, the first thing we need to note here is that we have 2 entities that are of different bases. This one is in base 10, while this one is in base 5. Here, the standard base is base 10. So what we need to do in this respect is to convert this to base 10. How do we convert to base 10? Simply, we have 23 base 5. To convert to base 10, we assume that this 3 has a 0 on it, then the next one, 1. So that is the trend, 0, 1, 2, if you have more than 2-digit numbers. So in this situation, we are having 2-digit number. We have 0 and 1. So if I'm to convert this to base 10, all I need to do is pick these 2, multiply by the base, then raise to power the number on the 2, 1, plus pick this 3, multiply by the base, then raise to power the number on it, which is 0. So you have a scenario like this. We have succeeded in converting this number to base 10. What do we do next? We try to simplify, and by simplifying, 5 raised to power 1 is 5, times 2 we have 10, plus 5 raised to power 0 is 1, 1 times 3 is 3, because anything raised to power 0 is 1. So in this situation we have 13, 10 plus 3, that is 13. Therefore, we have 23 base 5 is equal to 13 base 10. So in that situation, what it means is that I've converted this to base 10, and what I need to do now is just to equate x base 10 to 13 base 10. So this base can cancel out. That means our value, our x is 13. So the answer to this particular question is 13. Now let's look at questions that are commonly tested in UTME up to date. I will be doing it in a simplified fashion by simplifying those questions that are complex and I make it simple. So let's see some questions and the year that they were tested. Question number 1 says convert 27 base 10 to another number in base 3. So in the year we have convert 27 base 10 to another number in base 3, and that was tested in JAMB. In JAMB year 2015. 2015, question number 28. So here you have this number, and we are asked to convert it to base 3. Now, what the number here is in base 10. It is very easy to convert any number in base 10 to another number. But in case where you have the number in other bases other than 10, and you have to convert to another base other than 10, the first thing we do is to convert to base 10. Then after converting to base 10, then we now convert to that respective base. But in this scenario, we have it already in base 10, and the question asks us to convert to base 3. So all we need to do is just to resolve it to this 27, and we divide by the base of interest, which is 3 in this respect. 3 in 27, that is 9. Remainder what? 0. 3 in 9, 3. Remainder what? 0. 3 in 3, 1. Remainder what? 0. 3 in 1, 0. Remainder what? 1. And having gotten to this junction, the next thing is to now count it upwards. So if you have to count it upwards, that means we are going to have 1, 0, 0, 0. In what base? Base 3. So this will be the answer to that question. Now to question 2, which says that find the value of 11011 base 2 plus 10100 base 2. This is another JAMB question in the year 2010, and the question is question number 2. So this is what we are given, and we are asked to find the value of this. So that means since we have operation plus, so we are meant to add them up. So if you are to add them up, we have 11011. Then we have 00101. So we have to add it up. 1 plus 0. We are operating. It should be noted that we are operating on base 2. So 1 plus 0, 1. 1 plus 0, 1. 1 plus 1, we get to 2. We can't write 2 directly because our base operation is 2. So the number we must get must be lower than that base. So we cannot write 2 directly here. Since we now have 2, so we divide by the base, which is 1, then we have what? 0. So in this situation, we have to write 0, which is this, and carry this 1 to the next line. So we carry this 1 to the next line, we add that 1 to this, that becomes 1 plus 0, 1 plus 0, 1. This is another one again, 1 plus 1, 2. We cannot write 2 directly, we write 0, then we carry 1 to the next line. So 1 plus 1, 2. We cannot write 2 again, we write 0, then we carry 1 to the next line. So at the end, we are going to be having 1001011 is 2. So the answer to this question is 1001011 base 2. Question 3, which says that convert 72 base 6 to a number base 3. We are asked to convert 72 base 6 to base 3. So in this situation, we have to convert to what? Base 3. Here, we cannot convert this directly to base 3 because our base 10 is the standard base. So what we need to do is to convert this to base 10 first. After we have now converted it to base 10, we can now convert to base 3. But if this one is in base 10, just like the one that was solved previously, then that one is in base 10. We can convert directly to base 3. But in this situation, this one is in base 6. We cannot convert directly to base 3. Instead, we convert to base 10. So how do we convert this to base 10? 72 base 6. So just like the way I did that of the previous, we put 0, 1 here. We start with 0, first digit, then 1. Now, what is the first digit here? 7. So 7 times the base, 6, raised to power the number you have under 7, which is 1, plus 2 times 6, raised to power the number you have on 2, 0. So here we have 6 raised to power 1 is what? 6. 6 times 7, 42, plus 6 raised to the power 0 is what? 1. 1 times 2, 2. So we have 44 in base 10. So we can now convert this 44 base 10 to base 3. So how do we do that? We have 44 and we divide by the base of interest, which is 3. 3 in 4, 1. Remainder 1. Remainder 2. Remainder 1, sorry. Then 3 in 14, we have 4. Remainder 2, or that will be 12. Then 3 in this, we have 4. Remainder 2. 3 in 4, 1. Remainder 1. 3 in 1, 0. Remainder 1. Then we'll count it upwards. So we're going to have 1, 1, 2, 2, base 3. So this is the answer to question on that discourse. That's question 3. Then question 4, which says that if 2q3 base 5 equals to 77 base 8. So in this situation, if you look at these two bases, we discover that this one